Hello, welcome to this HMT lecture series on marine electrode technology, lecture number 4. I am Janaka, a senior faculty with HMT. I have sailed as a chief engineer for about 30 years and this is my 22nd year of teaching in HMT. Today we are going to discuss about the hazards of electricity. There are totally 5 hazards, namely shock, static electricity, fire, arc flash and arc blast. In this lecture 4, we will discuss only about the first two, meaning shock and static electricity. The other thing, fire, arc flash, arc blast, we will discuss in the lecture number 5 because all the other three are interrelated. We will go to the lecture. So, our main learning objectives of this particular session will be the participant will be able to learn the hazards in electrical system, dangerous effects of these hazards, controlling and mitigation methods. There are totally 5 hazards in the electrical system. One is shock, number 2 is static electricity, the fire, flame and explosion, arc flash and arc blast. The topics of 3, 4 and 5, they are basically a common topic. So, I am shifting this to lecture number 5. Today we will talk about the shock and the static electricity. So, what is shock? It is a flow of current or what I call normally is a charge flowing through the body. The flow purely depends upon the body resistance on an applied voltage. If your body resistance is quite high, the charge flow may be less. If the body resistance is quite low, the charge will be more. It's not the same. Voltage may be constant. The charge flow may vary according to the body resistance. If a person is frequently going to gym and building up the body, his body resistance will be quite high compared to a lethargic person or who is not doing much of exercise, etc. Again, the body resistance depends upon the condition of the body. A humid body will have less resistance compared to a dry body. So, this body resistance may vary depending upon the situation. Accordingly, the shock effect also may vary according to time. Shock can cause the burn injuries. We normally classify it as first degree, second degree and third degree burns. Normally these first and second degree burns, it is getting cured by the medical help. Third degree burn also sometimes if it is favoring the body it may be cured, but majority of the time it takes very long time and there is no guarantee for the third degree burn complete cure. The shock may create nervous disorders. Sometimes it may even cause death, what we call electrocution possibility. Persons can save themselves from shock by properly insulating themselves or by using proper personal protection equipment. One method. The second method is by providing a diverting path or the diversion path for the charge to flow. Normally we can provide an earthing system or a grounding system which may divert the current. Instead of flowing through the body, it may go to the ground. Mainly whenever we do the work on the electrical system as a part of the maintenance, as a precautionary measure, we normally ground the system after discharging the complete system for static charges, and then we ground the system till the work is over, so that by mistake any leakage current or anything is coming through, it may get diverted to the ground. So the grounding conductor or whatever we are using, the resistance should be less than the body resistance, so the current can get diverted. People are mistaking its shock is due to voltage. Agreed, there's a voltage there, but mainly depends upon the flow of current or the flow of charge to the body. So applied voltage even less. For example, my age is around 75 now. Even with a 24-volt battery or 12-volt battery, I can get a shock. There are some youngsters in the age group of 21 to 25. They don't even get a shock with the 440-volt AC supply. So it's all purely depending upon the thing. Of course, the voltage has got a criteria in the sense that the charge flow depends upon the voltage. High voltage means resistance remaining constant, charge may be higher compared to low voltage systems. So the IEC normally it stands for International Electrotechnical Commission. They are the regulating authorities for giving the regulatory requirements for the electrical installations all over the world. According to them, the power supplies fall into three protection classes based on the need for a protective earth connection. Normally, they call earthing. Grounding, earthing, both are one and same. So, this provides an easy path for diverting the faulty electrical current to flow instead of passing through the user's body or anything else, thereby providing the shock protection. Class 1, the electric shock is getting protected, the combination of insulation and a protective earthing ground. They call it as a class 1 user protection. The class 2 user protection is two levels of insulation, either double or reinforced insulation without the need for earthing. That means my insulation level is quite high. Insulation means what we normally define, which we'll see in a separate lecture. The insulation is to be tested for 2 times the normal or operating voltage plus 1000 volt as per IEC class. When I have such an insulation which has been tested for more than 2 times the normal operating voltage, maybe earthing may be slightly disregarded, but earthing is considered as one of the safest method for protecting against a shock. So the third method is where the input is considered to a safety extra low voltage, normally which may not create a heavy shock, very mild shock which may not be felt also. So before doing the job or anything, attempting on electrical system, turn off the power supply, use tags or labels to inform a switch that not to be put on till the job is over. Check thoroughly the electrical tools like portable tools or any loose wires or loose contacts, etc. See that they are all well connected, well tightened, and properly insulated. Preferable that electrical side, the tools are properly insulated, it will be better to protect the human being. Wear the protective clothing and rubber gloves, etc., which are all tested for a particular voltage as per requirement to prevent unnecessary danger due to the shock. Normally, the insulation, as a general rule, is tested for 2 times the operating voltage plus 1000 volts. Avoid moisture or wetness in the working spot, also in your body. If you are having a habit of sweating, better wipe the sweat, and in case you are wearing a gloves, put an inner gloves, a cotton gloves, and then on over and above that, you can use a rubber gloves so that the moisture can be absorbed by the cotton. In case you are sweating too much, then change the gloves frequently. The insulating materials or insulating this thing, whatever you are using, it's of the approved type. The lockout tagout procedure is normally followed on board a ship, preferably even outside also. We put out the breaker, circuit breaker, and then lock it so that nobody will, even by mistake, they can switch it on. Put the tag regarding the working and how many hours it's going to take. Work permit has to be given. Normally, this permit to work is given for 12 hours on board the ship. At the expiry of the 12 hours, you are supposed to renew this permit to work. And the systems are provided with the proper grounding arrangement to discharge the static charges. That has to be done, and ensure that all these things are followed before you start the work. Static electricity. General definition is static electricity is formed due to friction between two surfaces. Static electricity means this electricity which is not flowing, or the charge which is not flowing, but charge gets stored. It can only charge and can discharge when that conducting path is stored. Suppose this discharge takes place through your body, because your body is getting earthed, touching the floor or something, barefoot, or your hand may be touching the wall or something. Depending upon the amount of discharge, if it is a mild discharge, it may cause only burns. Major discharge will straight away kill you. Again, the mild discharge may cause something paralytic effect, nervous disorders, etc. The discharge of the static charges, it is not for long hours, it will be a momentary, maybe in terms of milliseconds or seconds. If there is a vapors present within the flammable limits, what we call flammable environment, flames may be created, which may become dangerous, it may engulf the larger area, and on board the ship, it's very difficult to control. So we normally say that in hazardous areas or hazardous zones, we avoid such equipments which may create static charges, or well before the work is started, we ground all the probable equipment which may have this static charge. For example, in a crude oil tanker or something where we have got the loading of the cargo, etc., the pipelines, the manifold, they are all getting statically charged. So well before the cargo work starts loading or discharging, we ensure that these pipelines are grounded to the hull of the ship. And mainly all the pipelines will be grounded. The tank, sounding pipes, etc., they are all properly grounded. So the grounding is the only solution by which the static electricity can be removed, or it can be completely taken care of. That's the reason we discharge the static charges by grounding using a portable grounding system. How the static electricity is produced in MSB. You have three bars. Sorry, my hand movement is little shaky. If you say these are the three bus bars in representing RYB, remember in the first lecture I told you that there are three basic Mula mantras which we have to follow. When current is flowing, for example, this is the MSB which is loaded. Naturally, it will have a current flow in the individual bus bars. As the flow of current can produce magnetic fields, these bus bars will have sort of a magnetic field surrounding them. And theoretically, we say that these three bus bars are 120 degrees apart, which we can't measure, or which we can't see with a normal eye. But there are magnetic fields surrounding that. Because of this magnetic field, and they are separated by 120 degrees apart, there is always a attraction, repulsion of the bus bars. This attraction and repulsion creates a friction between the gap between the bus bars. The attraction, repulsion of these magnetic fields, which create that amount of attraction, repulsion depends upon the frequency of the supply. The bus bars, they literally attract and repel, attract and repel. We can't see again. So frequency is quite high. So the space in between the bus bar, they are getting statically charged. So even though the circuit breaker is off, the voltage shows zero. The static charges are still there. It may affect the person who is going to work. So we have to discharge the static charges by using portable grounding system. These type of static discharge rods are available on board the ship. You see the yellow cable. There's a clamp which can be grounded to the floor plate or angle, whatever is connected to the hull of the ship. And this red color is a telescopic type arrangement which can be extended up to 25-meter length. And this is the copper conductor there, which can be touched with the MSB, the bus bars. And this is connected to the ground. Thereby, the bus bars will be discharged. The static charges will be discharged. Momentarily, there will be arcing. We need not get afraid or anything like that. But once the arcing is over, that means that the static electricity has been discharged and the thing is safe to work with. And these type of portable clamps are also available on board the ship, normally given. If it is not there, we have to order for it and get it. You see, this is the common ground connected to the floor plate or the angle, and these three are the clamps connected to the individual bus bar. This will remain like this till the job is over. Even though the static electricity is not there now, for better safety purpose, this grounding is done and made a note of. So that once the job is over, first we have to remove this grounding and then say that job is over, take the permit for testing the equipment, etc. So this grounding has to be there. If this is not supplied, then you have to make a tentative arrangement by having cables, etc., wires, etc. We have to keep the grounding on until the work is getting over. Same if you see a 3-core cable on board the ship, preferably 3-core cable, we are using it for the 3-phase. 3 cores are there, color shown here RYB. I can use it for the 3-phase connection. And we got the insulation and we got the covering, etc. This 3-core cable, remember, when the current is flowing through the individual phases, there will be a magnetic field here. This magnetic field is going to create the static charges that will be stored in the insulating material in a larger way. So it is posing a continuous risk that whenever the current is flowing continuously, there will be static charges in the cable. To eliminate them, on the upper layer we have got something called a metallic braiding or armoring provided. This armoring is, you see that lug with that material, that same thing like a braiding material. Through a lug, it is connected to the ground. As per IEC recommendations, it is preferable to have this grounding every 4 meters. So that operating personnel, they are safeguarded against these static discharges. By chance, my body is wet and I'm touching this cable. If I don't have the proper earthing, there may be the static discharge may take place through my body. So these type of safety precautions are given, which we have to strictly follow. We have to follow that. Sometimes the static discharge taking place in the body, it can cause paralysis or severe burns, something damage to the complete nervous system, etc. The frequent usage of cell phone, especially keeping the phone in contact with your ears, may cause static discharge, because majority of the time we Indians normally we walk with the barefoot at home and all. Our body is getting always grounded. The cell phone, people are talking about the radiation, alpha, beta, gamma radiation, etc. More than that, they should think of one more thing. There's an antenna in the cell phone. The antenna is always getting charged whenever I'm putting it into use. This charge will develop the static charges. Actually, this is static charge. It doesn't discharge anywhere unless it is grounded. And you've got that insulating cover on the cell phone. Normally, this antenna will not discharge. The charge will be still remaining. But you are providing a earthing connection by keeping it near your ear and body touching the ground. So this antenna charge will pass through your body to the ground. Initially, people may not feel this discharge because it will be very, very minor. But continuous usage, slowly your nervous system will get affected. Please be careful. My sincere request, even though I'm talking about marine electrotechnology, but cell phone is also equally important. People are using frequently on board the ship also. My request, one more thing is for general public, don't give the cell phone to your children who are with a bare body, crawling on the floor, etc. This discharge will take place through the body. They cannot withstand. You can withstand because you are having some body resistance. Kindly follow the safety. As I told you, the 3-core cables won't have static charges as long as there is a current flow. Cargo tanks and pipelines in tankers where the flow of liquid is taking place, there is a friction taking place, mechanical friction between the liquid and the metal part, there will be static charges. Cargo holds in a general cargo ship and bulk carriers where they carry the loose cargo, or while loading and discharging the cargo using the grabs, etc., it may have the static charges produced. Fuel tanks like service and settling tanks where the transfer of oil is taking place. I take the oil from the purifier and send it back to the service tank. Possibilities. These are all the places where the static charges will be there. Wherever the liquid or this thing is having highly insulated, the static charges will store. Coming to the end of the lecture, hope you enjoyed this lecture and it is quite useful to you. To summarize, understand shock is due to flow of charge through your body that purely depends upon your body resistance. Mitigation methods, properly insulating yourself. The other one is grounding so that the current can be diverted to the ground instead of flowing through the body. As far as static electricity is concerned, we have to protect ourselves. Mainly ensure that the different equipments are properly grounded, because static electricity can be prevented only by grounding that can discharge into the ground. Never try to use your cell phones etc. onto the air with your body grounded, like standing with a barefoot in the house etc. Even though the charge may not be felt immediately, over a period of time it will affect all your nervous disorders. Both the shock and static electricity, they may cause a nervous disorder or a death possibility. Let us avoid this. Thank you for your patient listening. We will meet in the lecture number 5, wherein I am going to discuss about fire, arc flash and arc blast. Thank you very much.